In this video, we are going to discuss about what is a process and how a process is represented in main memory. First, let's see what is a process. Process means a program in execution. We know what is a program. Program means a collection of instructions which are useful in order to perform a specific task. Whereas what is process? Process means a program in execution. Let us take the example of a C program. So first we have to compile the C program. During compilation, the program will reside in hard disk. But at the time of execution, operating system loads the program from hard disk to main memory. Why? Because any program is executed with the help of CPU. CPU can execute a program if the program resides in main memory only. CPU cannot access secondary memory such as hard disk. CPU can access only main memory. So during execution, operating system transfers the program from hard disk into main memory. Now the program is available in main memory. Now this program is called as process. So process means a program during execution. During execution, operating system loads the program from hard disk to the main memory and it is called as process. So that is the major difference between program and process. So process means it should be in main memory only. Now let's see this diagram. Every process is represented internally in main memory in this format. So here we have several segments. The first segment is text segment, next one data segment, next one heap segment, next one stack segment. These are nothing but address locations. The minimum address is 0, whereas the maximum address is max. First, let's see what is text segment. Text segment can also be called as code segment. So the other name for the text segment is code segment. Text segment mainly stores program. So every program contains several instructions. So it stores instructions of the program. Let the program contains 10 statements, 10 instructions. So those 10 instructions will be stored in the text segment. What is the other name for text segment? Code segment. Now let's see what is data segment. It mainly stores global variables as well as static variables. We know what is a global variable. Global variable means we can use that variable throughout the program. So let we have 100 functions in the program. If we want to use a common variable in all the 100 functions, then we can make use of global variable. And we know about static variable. For static variable, the memory will be created only once and all the functions will make use of that variable. Okay. So data segment is mainly useful in order to store global variables as well as static variables. Global variables as well as static variables. So if there are any global variables and static variables in our program, then those variables will be stored in data segment. Okay. And the next one is heap segment. We know what is dynamic memory allocation. So dynamic memory allocation means the allocation of memory during runtime. Generally for pointers, the memory will be allocated during runtime. So here heap section is mainly useful in order to store variables whose memory was allocated during runtime. So let we have 2 pointers. So for those 2 pointers, the memory was allocated during runtime. So those variables will be stored in the heap. So heap is mainly useful in order to store dynamically memory allocated variables. Okay. So why we are using heap here? It is useful in order to store dynamic memory allocated variables. Dynamic memory allocated variables. Okay. And here we have one more section, that is stack section. Stack section is nothing but it is also called as function stack. So here we are using stack mainly while calling the function. So whenever we call a function, then the function should contain some parameters, as well as function should contain, within the function we can have some local variables, some temporary variables. We can use those local variables or temporary variables in that function only, as well as it should return some value. Okay, so all those parameters will be stored in the stack. So what is the other name for stack? Function stack. So why we are using stack? Stack is mainly useful in order to store function parameters. So we can store the function parameters as well as local variables. These local variables can also be known as temporary variables. Why? Because we can use those variables only inside that function, as well as if it returns any variable, okay, that return variable, okay, that return variable can also be stored with the help of the stack. Here heap always grows upside, whereas stack always grows downside. Why? Because we don't know which segment will use us more memory. Let us assume that we have a program called program 1. In program 1 we are using more stack memory as well as less heap memory. So in that occasion what will happen is stack will make use of more memory as well as heap will make use of less memory. So that's why we should not split stack and heap. Okay, so depends upon the stack and heap, they will share. Let us assume that in certain program heap memory is very high, whereas stack memory is very less. Okay, so in that occasion heap will make use of more memory as well as stack will make use of less memory. Okay, so this is about what is a process and what is the difference between program and process, as well as how a stack is represented in the memory.